SP025 capacitor with dielectric. Okay, actually, what is dielectric? What is a dielectric? A non-conducting, or sometimes we call as insulator, material placed between the plates of a capacitor. Let's say paper. We have a few types of dielectric: paper, oil, glass. Okay, so as a insulator. Now, proceed to definition of dielectric constant. The symbol is epsilon R. Epsilon R. The ratio between capacitance of a given capacitor with plates filled with dielectric C and the capacitance of the same capacitor with plates in vacuum C0. So refer to this statement. Dielectric constant is the ratio of capacitance dielectric to the capacitance in vacuum. Alright. So next, this one is a permittivity in dielectric. This one is a permittivity in the free space. Okay, look at the constant here, the list of selected constant here. So where your E0? E0 here. Permittivity constant. This is in vacuum. Alright. Okay. From here, so we can state for the dielectric constant, no unit because of capacitance in farad, even though with dielectric, over capacitance in vacuum also in unit farad. So cancel out. So that's why no unit. Now we want to discuss dielectric effect parallel plate capacitor. Before that, what is the advantage when insert dielectric between the plates? Advantages. First, increase in capacitance. So the main idea, dielectric will increase capacitance. Alright. And then also increase the maximum operating voltage. This one is V overall. V system. Okay. Now look at the explanation. I will explain to you using the same diagram but in different medium. One in vacuum, another one in dielectric. Okay, look at the vacuum first. Means what? Okay, between this plate, so this is air. Okay. Air. Okay, what happened? This is the battery. So, when the circuit connect to the battery, so what happened to the plate of capacitor? So, this plate will accumulate, collect the charge. Okay, positive because of here positive, negative here because of negative terminal. Okay, now what happened when this positive plate and this one negative plate? So will produce uniform, will produce uniform electric field E. Alright. So now, when the battery disconnected, meaning without battery, okay, what happened? Okay, so now what happened here? The same charge here, okay, remaining accumulate. Remain accumulate. So now still have electric field here SE. But now when insert with, let's say, a paper, okay, a paper insert between them. Okay, what happened here? Look at the electric field here. What happened to the electric field here? Okay, so what happened to the electric field here? So electric field produced here will decreases. Alright. Okay, now what happened during the electric field between the plates? Okay, first, distance between two plates. Okay, where? Here and here. Same or unchanged. So what happened during charge from battery and with battery and without battery? The charge is constant, meaning the same charge accumulate on the plates. Okay, so what happened for the potential difference here? So when Q is constant, right? So C and V inversely proportional. So when capacitance increase because of paper, so V decrease. Okay, next. What happened to the capacitance? So capacitance increase. Okay. Why capacitance increase? Because of dielectric. So dielectric here, let's say paper. And the last part, electric field strength. What happened during here? Here. Okay, for this case, so decrease. And then relate to the potential difference. When D constant, so what can we state? V directly proportional to E. A parallel plate air capacitor is charged to V volts and disconnected from the charging voltage. Then, the space between the plates of the capacitor is then filled with an insulator. Explain what happened to. Alright, so basically from this question, so look at the main concept here. Okay, during disconnected, the total charge is constant. The second concept, insulator here, okay, will increase the capacitance. Now, look at the first answer. What happened to the capacitance? So because of, finally, after disconnected, so the capacitor will fill with the insulator here. Therefore, capacitance increase because of dielectric. Alright. So next, the total charge is constant. Then, when the Q is constant here, when you apply equation C equal to Q over V, so we can see here, the relationship between C and V is inversely proportional. When the capacitance increase because of dielectric, what happened to the potential difference? Decrease. So the answer is decrease. A 6 microfarad capacitor filled with air. So we can consider this value is capacitance with air. And then charged by 12 volt battery. So consider the battery or the potential difference in air. So it is disconnected. So the main concept is during disconnected, so the Q is constant, right? Okay. The battery and the space between the plates is filled with oil. So oil with the dielectric constant. So oil become the dielectric. Alright. So calculate the new potential difference. Okay, basically using the dielectric constant. So this is a dielectric constant equal to capacitance dielectric over in air or vacuum. So now refer to the dielectric constant ER. Then we want to determine the capacitance with dielectric. So this is the capacitance in air. So we get capacitance in oil, means dielectric is here. 1.5 times 10 to the power of -5 farad. After that, we want to determine the new potential difference. Alright, so before that, so we need to calculate the initial charge. So using C equal to Q over V naught. So this is vacuum, charge in vacuum, and the potential difference in vacuum. So we get the charge in vacuum. Then back to the main concept during disconnected. So Q naught initial or the charge in vacuum equal to the charge in dielectric equal. So what happened here? So when we want to calculate the new potential difference here, so this is the new capacitance, meaning oil. This is the potential difference for the oil. And then we will get here. So Q here should be equal to initial charge. So substitute, and then finally we get the new potential difference in oil equal to 4.8 volt.